Welcome to Stupid Physics Tricks. Remember, this is just a demonstration. It's not on the examination, so please, no studying. This week, I'm going to do the stupid physics trick again, and it's based on these holiday lights. So let's think about the circuit involved in these lights. You plug it into the wall, so you have about 120 volts, and that goes over each bulb, and each bulb is basically acting like a resistor. So you might ask yourself, should we wire them up in series or should we wire them up in parallel, right? If they're in series, then you apply 120 volts to all of them sequentially, so that voltage drops over each one. So if it's 120 volts and you've got about 60 bulbs, each bulb would have a drop of about 2 volts. That sounds reasonable and safe. You could also wire them in parallel. Wire them in parallel, each bulb would be at 120 volts. Maybe that's not such a good idea, and it would take a lot more wire. So usually you wire them in series. And the problem with that is if I pull one bulb out in series, they all go out, right? And if I put that one bulb back in, they all go in, or they all go back on. So removing one bulb stops all the current in series. So this brings us to the trick. And this is the problem with series, by the way, which is if one bulb goes out and I'll put it back here and say it went out because I didn't pull it out, and then you look at it and you don't know which bulb went out, right? And then you go test every little bulb trying to figure it out, right? That's the bad part of series. That wouldn't happen for parallel. But the advantage is each bulb only at 2 volts. And that brings us to the trick. It helps when you're trying to decorate with these if you're really fast at rewiring them. So what I'm going to show you is that I can break one of these bulbs and I can rewire it so fast that the lights never go out, okay? So when one of these bulbs breaks, what you'll see is the filament suddenly starts to oxidize because it's suddenly exposed to air, and it gets kind of brighter for a second, and then it goes out, and it destroys the bulb. Right? So that's what we're looking for. What I'm going to show you is I can break one, and then with my tools and my left hand and really fine wire, I can actually sort of drop a little piece of wire across the leads to the filament in time that it never goes out. Okay? So first I'm going to cut off a little piece of my fine wire here. Okay, the fine wire is ready. And I'm going to grab the top of the bulb and I'm going to pop it off, and then instantly I'm going to rewire it. You ready? Here we go. They didn't go out. You saw the bulb go away. These are still here. Not bad. You want to see it again? Of course you do. I will assume thousands of people said yes in unison. Let me get another piece here. This isn't one of those one-time pre-set up magic tricks. All right, I got my thing here. Grab the bulb. Get ready to break it. Okay. Again, I got it in time. So they're in series, somehow it keeps going. And that's the trick. And now what is this, the rule of stupid physics tricks? It has to be stupid, okay, we've accomplished stupid, and I have to explain the physics. And here's the physics. There is a lot more going on in these bulbs than you think there is. So when you put 2 bulbs in series, or a bunch of bulbs in series, the problem is one burns out and they all burn out. So let's think about the bulb for a minute. Let's think about the whole circuit. It's a bunch of resistors in series, like that. One goes out, they all go out. We showed that. Yet somehow when I broke it, they didn't all go out, even though the one bulb clearly went out. So what's happening is inside each bulb is actually a wire that can serve as a short circuit. So it's a wire, and with a short circuit, I'll just draw it like this with no resistance. It's a wire with very high resistance, or with very low resistance. So if the bulb were to burn out and you had a short there, it's just like a piece of wire, right? No voltage drop, all the current flows through nicely. But that short isn't actually connected directly. It's connected with some really thin plastic layer. It's a little thin piece of plastic between sort of the lead on the bulb and the short. That piece of plastic acts like a huge resistor. Okay? So 2 huge resistors on each lead. So if you have a huge resistor here and just a normal bulb resistance here, then this also does basically nothing, right? Most of the current goes this way. The voltage drop is defined here, and this is like, it's just like a resistor not even sitting there, okay? So what happens is when you break when you ruin the filament, like I just killed the filament with my pliers, that plastic melts. Current flows through there, and it melts the plastic. And suddenly, when it melts, it's gone, and you have a short. That's how it works. Now, if you really understand your circuits and your series and your parallel, that didn't quite satisfy you, right? Because when the filament breaks, and I have the big resistor there, and the big plastic, what changes for the plastic? Well, nothing, right? It was a big resistance, so no current flowed, and now it's a big resistance, so no current flows, right? A little voltage drop isn't going to make current flow, except suddenly what happens is all the voltage that was across all the other bulbs, all is concentrated only across this bulb, right? If we add all these up in series now, this now has a huge resistance. It gets all the voltage. So all 120 volts are across the little plastic between the leads of the bulb and the short. So actually the current does spike through here. So the current spikes through here, burns out the plastic, turns it into a short, and then the voltage is redistributed to all the bulbs. And all that happens faster than what you observe, basically faster than the time for the filaments to heat up and cool down. All that's happening when the bulb burns out. Pretty amazing. And of course, in this case, when the bulb burns out, the rest of them stay on, and you know which one is the culprit, and you can take it out. One other little thing that I think is fun about this demo/trick is that as we pop bulbs out, what are we doing? Well, if we pop bulbs out, each bulb is getting more and more voltage, and therefore it's getting brighter and brighter. Right? So what we can notice is if I start breaking a lot of these bulbs, you'll see the string get brighter and brighter and brighter. And what I've never done is do that to the limit. Maybe we'll be able to get 120 volts across one of these bulbs. Don't know, never done it before, let's find out. I'll start popping them. And I forgot my eyewear today. There's another one there. And let's just start taking them out. Okay, I need to do it maybe a little more aggressively. I don't want this video to be too long. Let's see, can we tell yet that it's getting brighter? Not yet, there's so many of them. So I need to go a little faster. Right. Let's see, is it brighter? I think it's a little brighter. Oh, and that was it, right? It can only go so bright. And then, what did it do? Did it burn them all out? I know what it did. There's a fuse in here. If you take this apart in the back, there's a fuse. And I bet you we just burned it out. Because our resistance went so low, our power went too high. I'll check the fuse and get back to you later.